In problem number 2 of this problem set, we have f as a continuous function that is defined for all real numbers and that has the following properties. Integral from 1 to 3 of f of x dx is 5/2. Integral from 1 to 5 of f of x dx is 10. The first thing that we want to do is to find the average or the mean value of f over the closed interval from 1 to 3. So when we see that we're looking for the average value of a function, this brings us to the idea of the mean value theorem for integrals. And that states that the area under some irregular shaped curve is equal to a rectangle that has the same width. So the base of that rectangle would be b minus a, and it has a height of some value of the function. So we'll call that f of c. So it's the base times the height, where c is some value in between a and b. And simply solving that for f of c, we get that f of c is equal to 1 over b minus a times the integral from a to b of f of x dx. So in this case, f of c is considered to be the average value of f over the closed interval from 1 to 3. Sorry, in the general case it's from a to b. And a simple way for me to remember the average value of the function is I call it the integral, which is the integral from a to b of f of x dx, divided by the interval, which is b minus a. So it's really integral from a to b of f of x dx divided by b minus a. And instead of dividing, we just multiply by 1 over b minus a. Now in this particular case, we're looking for the average value of f over the closed interval from 1 to 3. So that's 1 over 3 minus 1 times the integral from 1 to 3 of f of x dx. Now we're given above that the integral from 1 to 3 of f of x dx is 5/2, and so we want to multiply that by 1 over 3 minus 1, which is 1/2, and so the final result there is 5/4. And that's the answer to part A. Now for the second part, we want to find the value of the integral from 3 to 5 of 2f of x plus 6 dx. And what the strategy we're going to use here, first of all, is to just break this integral down using our properties of integrals. And so we have the integral from 3 to 5 of 2f of x plus 6 dx. We're going to break that down into two separate integrals. And using the constant multiple property, we're going to move the 2 outside the integration sign. So we get 2 times the integral from 3 to 5 of f of x dx. And secondly, we have plus 6 times the integral from 3 to 5 dx. Now, based on what we're given above, we have an integral from 1 to 3, and we have the integral from 1 to 5. Well, the integral from 3 to 5 is just the integral from 1 to 5 minus the integral from 3 to 1. And so we have 2 times the integral from 1 to 5 f of x dx minus the integral from 1 to 3 of f of x dx. So that's going to give us the integral from 3 to 5. And the integral from 3 to 5 dx in the second part, well, you can think of that as x to the 0 power. We're going to increase that by 1, divide by 1, and we get x. Evaluate at the upper limit, it's 5. Evaluate at the lower limit, it's 3. But I just think of that as the derivative, as the integral of a straight line of height 1 from 3 to 5. So it's a rectangle of width 2, height 1. So that's 2. And finally, the integral from 1 to 5 is 10. So we have 2 times the quantity 10 minus, and the integral from 1 to 3 of f of x dx is 5/2. So on the left side, multiplying 10 by 2, we get 20. Multiplying 5/2 by 2, we get 5. And the end result is 27. And so that's the answer to part B. Part C is given that f of x is ax plus b. We want to find the values of a and b. So we're just going to use the two givens above. So we know that integral from 1 to 3 of ax plus b dx is 5/2. Antiderivative is ax squared over 2 plus bx. We're going to evaluate that at 3 minus evaluate it at 1 and set it equal to 5/2. And that's 9/2 a plus 3b minus quantity 1/2 a plus b equals 5/2. 4a plus 2b is 5/2. Or 8a plus 4b is equal to 5. Now we also know the integral from 1 to 5, ax plus b dx is 10. We have the same antiderivative. Evaluating at 5 minus evaluating at 1. That gives us 25/2 a plus 5b minus a quantity 1/2 a plus b is equal to 10. Simplifying that out gives 12a plus 4b is 10. So we have the system of equations 12a plus 4b is 10, 8a plus 4b is 5. Subtracting, we get 4a is 5, a is 5/4, and substituting, we get b is negative 5/4.